Welcome to this demo of the IOTech Alarm Service. In this video, we'll demonstrate how our alarm service delivers a unified, standards-based solution for managing and handling alarms at the edge. As a quick reminder, IOTech's Alarm Service provides a comprehensive and unified approach to alarm normalization and management. It is technology agnostic, which ensures it can handle and manage alarms from a whole range of different operational technologies. The solution is built on well-established industry standards like OPC UA alarms and conditions and is aligned with IEC 62682. During our demo, we are going to model and raise alarms using a Modbus-based industrial controller device. Here we are going to show three different alarm types. A discrete alarm for the controller's safety door becoming open, a deviation alarm for varying temperature values, in this case modeling 80 degrees as the standard temperature, with deviations of 5 or more indicating a high alarm and 10 or more indicating a high alarm. And by the way, we are using the standard terminology from the underlying alarm specification. And also an offline alarm, so we can be notified if the device becomes unresponsive. Note that many other alarm sources are supported, such as MQTT, rules engine or analytics-based alarms, but just not demonstrated here. A key feature of the IOTech Alarm Service is its comprehensive alarm state model that is defined as part of the underlying standard. Each alarm can transition through a rich set of well-defined states, such as active or inactive, acknowledged, confirmed, shelved, suppressed, and so on. We'll demonstrate some of these different states in our demo here. So the Alarm Service has its own REST API, but we'll use the Edge Central User Interface to drive the demo here. As you can see, we have the controller device already registered to Edge Central. We also have a dedicated set of menus for the alarms. In the main alarms view, we can see that no alarms are currently active or have been triggered. But if I change the filter, we can see all of the alarms that might be raised here. We've got the 3 alarms I mentioned, all related to our controller device. The configs menu shows the user-defined alarms in our system. If I just look at the temperature deviation alarm configuration, we can see some of the values here. Firstly, the standard set point is 80, as I said, and then the high and low levels based on that. We can have a lot of detail here if we want to, including severity levels and so on. We could also define new alarm configs on the fly with the UI here. The associations menu shows which devices are able to raise which alarms. So here we're saying both configs apply to our controller device, but again, you can be selective and apply these on the fly with the wizards here too. So back on the main alarms view, we can see that no alarms are currently active or have been triggered. So let's raise some alarms. First, let's open that safety door. We can set the controller's door status to true here using the UI. Switching back to the alarms menu shows the alarm is triggered and appears in our list here. We get information about what alarm has raised, on which device, at what time, the severity levels, it's active, and so on. Typically, there is a life cycle of states associated with an alarm. With the alarm active, the first step usually is for the operator to acknowledge that alarm, to say they've seen it and are aware of it. We can add a comment if we like. Another state change might be to confirm you are taking an action to handle that alarm. And there are lots of other states you can set on that alarm too. Perhaps now the door could be closed. If we set the door status value to false, then our alarms view will show that the severity has gone low and the status inactive. That's good news, as obviously the door is now shut. What we can also do here is view the history of that alarm. When did it fire, what actions were taken, all the timings and so on. All of that detail is maintained by the alarm service, so you can analyze behavior and better address operational issues, etc. Let's now show the deviation alarm in action. If I set the temperature to 85 or more, that should trigger our first alarm deviation. And you can see that raised on our alarms menu here. If I set the temperature to 90 or more, that will trigger our high critical deviation, which you can again see on the UI. As before, you can apply different states and so on if you like. Okay, good. So next, we're going to show how an edge alarm can be automatically handled and routed to another system. Let's use email to demonstrate this. The routing system decouples the alarm conditions from the alarm endpoints or actions. I've got a condition set up here which lets you pick which severity levels or alarm types we want to act on. This one just selects all alarms. I've got an email action here which describes the format of the email and where we want it to be sent, like the SMTP settings and so on. And then alarm routes link these together. So here I'll associate the condition with the action. You can also describe the times or days when the email should be delivered. You can configure delays and retry periods, and you can configure exactly which alarm state changes should trigger the action. Here let's say when active and when inactive. So at the moment, as you can see, no emails are currently in my inbox here. But if we reopen the door, we should see that the door open alarm becomes active again. And therefore an email should be received from our alarm routing. Yes. I can close the door again and receive another email as it becomes inactive. You can have as much detail as you like in these emails, by the way, with all the content configurable in the templates menu. And finally, let's show the offline alarm. I just need to simulate a network issue or the device becoming inactive, and I can do that by just killing the container for my simulator. The Edge Central devices have a configurable wait and retry period before they're noted as offline and get marked as down. Okay, that's happened now. We can see the alarm triggered for that here. And then we should also get an email from our alarm routing. Yes, there we go, great. Okay, good. That shows how the IOTech Alarm Service can configure, receive, handle, and then deliver a wide range of edge alarms to external systems in a standard and convenient way. As you can see, the alarm service is extremely rich in functionality, yet easily configurable by the user, both via its REST API or advanced user interface. Thanks for watching. For more information, visit iotechsys.com.